We're going to go ahead and begin. As Farouk explained, my name is Abdullah Rashid. Most of the side of the room knows me, or if you haven't, then if you haven't known me for a long time, then we just met at least, and then it's nice to meet you guys. And as Farouk mentioned, in about 2012, I had graduated college. I was broke, and I was trying to start my own business. And Farouk met him at a conference, and someone told him about me and what I was doing, and then he made some recommendations. And then those recommendations led to me acting on those recommendations, and then becoming one of his mentees. And then from there, I just shot off. I always have access to him. Took his advice. Everything he said worked, thankfully. So I went from making $5,000 a year to making $75,000 a year, and then from there, you know, 6 figures and beyond. And then my brother, he was in college. He followed the same steps that Farouk gave to me, and he didn't even finish before he got a job for $80K. $80,000, and then from there he's moving as well. And then now we have like a little tribe of people that are just following the same way. So you know, Farouk is a good person to if you have young talent here. He's a really good person to help groom talent. Excellent mentor, and getting that talent in front of somebody that's fearless, like he is. Like I mean, he will literally jump out of a plane without a parachute, and you're like, you know, he'll just hit the ground and just like roll over and stand up, and you're like, man, what? How did you do that, right? That's like literally what happens. Like, I mean, it's all guys in here. Like, he literally will like make your nuts hang. More. Like, whenever I'm around him, I think like my gonads just grow more. just being around Farouk, you know. And so you need that kind of leader, you know, and your people have to be around that kind of leader. So when faced with challenges, big time challenges, big dollar challenges, big technical challenges, they won't be fearful of staring that challenge in the face and going at it no matter what it takes. So my portion is. It's titled Create Highly Integrated Big Data Mobile Apps That Work Offline and Online. So I'll kind of, you know, we'll kind of detangle that, what that means. And we are using apps that use big data, and some that work online only, and then some that work offline as well. The experience doesn't change when you lose internet connectivity. And that's important in certain apps. So we'll like kind of go into what that will entail. So here's a kind of table of contents. We'll have a brief introduction. We'll kind of talk about the topic and why it's important. And then I have a use case. We had a 200 and, well, it's higher than that now, but at the time it was a $250 million problem that needed to be solved with a B2C app for a big client in Canada, but now it's a $1 billion problem, and we created a solution. We actually have a white paper that was developed from the solution that showed that our app provided a solution through education and gamification of their experience and with this particular client, their customer base, among millions of people. And then we'll break down the tech, the data, middle layer, as Farouk was referring to, and then the details of the inner workings of the mobile app. So this will go into, we have the data experts here, Farouk, Brother Shahid. So I'll be talking more about the mobile app and the details and some of the things that I wanted to develop in the mobile app. I'll quickly just cover software architect for about 7 years. I'm a full stack developer specializing in JavaScript, Node.js, Angular, React, React Native, Vue.js, SQL, NoSQL, Xcode, Swift, Java, and more. Many of the tech guys that have been around for a long time, you ask them what tech they've used, they have a long list of languages they've learned or used or have been in situations where they had to use many different languages. And after a certain point, it's like you use what you have to use, right? There's certain people that are married to certain languages, certain frameworks, and they're diehard, they'll go to bat for them. But at a particular point, when you're looking at things from a high level, you're looking at efficiency, you're looking at what the skill level of the team is, and you'll use what's the best fit for the particular solution you're deploying. So I also worked as a UX, I think it's working now. I also worked as a UX designer as well, which comes in handy as a front-end developer, because most of the times the design team will hand us a design, and the developers will exacerbate it, like they'll destroy it, and the design team is like pissed off, and we have to go through all these back and forth things. So as a lead, before we present the design or the implementation back to the business team, I'm scrutinizing the developers in a good way, right? In a healthy way. And letting them know, hey man, we have to tighten up these paddings and margins that the designers are very are meticulous about, right? Just like, man, it's five pixels, right? But they're very meticulous about the pixels, the color matching, fonts, etc. So that has helped me. And then I've also worked as a project manager in program management, which also helps as a lead, because we all know that project managers they're very valuable. So one of the first projects Farouk threw me into, he's like, yeah, I took this big contract, big project, and like he just disappeared. And we're like over scope, over budget, and the client is pissed off. And like I had to hire all these people. I had to hire, and one of the first things first person I hired was a project manager, and this guy was like amazing. So at that point, when I was like all the way in the hole, the project manager was one of the keys to help us get in line and have those daily, scrum meetings and whipping people into shape, etc. So that's something, and you guys are all in the space, so I don't have to go too far into it. But yeah, so apps that I've built everything from progressive web apps, single page apps, both hybrid and native mobile apps, using most of the device-specific functions, device location. So we did geofencing, taking pictures, accessing gallery, accessing contacts, sending messages or initiating messages, recording audio, taking video, using an accelerometer, everything that's device specific. And that's when it really gets interesting when it comes to mobile development, when you're using device specific things to develop your app and create a good experience. And then a lot of different solutions that have both a web interface and a mobile interface. So if I'm using Amazon.com, I can purchase from my web account, or I may have the app. So my account has to be synced. The experience has to be similar. So I've led efforts in that manner as well. There's a few just quick clients that we did some big apps for. Chevron, World Fuel's a big jet fuel company in the States. We've done stuff for universities, so this is University of Houston and Houston, Texas. Oshawa Power is a Canadian government energy company. Entergy is a large energy company that has cross-state customer base, Texas and Arkansas, Louisiana, and other states. Pilot as well. Just to mention a few that we did like multi-million-dollar projects for, and that's a little bit about just kind of what myself, some apps that I've been involved in, and some of the customers that we serviced. This topic of creating highly integrated big data mobile apps that work offline and online. Why is this important? At one level, a mobile app developer, if he's siloed, if he is only looking at small pieces of code that he's developing, big data may not matter to him because he's just developing functions, right? He's just doing CRUD, right? He's just like, maybe pulling in some data and displaying it on the screen, or submitting a form, grabbing inputs from a form and submitting that to the back end. So at one level, of a developer, he's only seeing in that narrow space. Big data doesn't matter. But for an architect that understands the business case, understand the business problem, and understand that the tech that they're building is actually helping the business solution, big data is extremely, extremely important. So I'll read a quote real quick from Uber. This is on their engineering blog, Uber's engineering blog. So they said, Uber relies heavily on making data-driven decisions at every level, from forecasting rider demand during high traffic events to identifying and addressing bottlenecks in our driver partner sign-up process. You can imagine that the apps nowadays that are using big data, you have, as a business, you have direct access to your customer and their device that they're carrying with them all the time. They had a study that said that a certain amount of percentage, I can't think of it now, a certain amount of percentage of people, they read most of their news on the toilet, right? On their phone, right? So it's like, I wake up, I'm reaching for my phone. I'm on the toilet, I have my phone with me, right? So if you can start to, one, understand how the user is using your app, you understand the behavior, what pages they're visiting, what times of the day they're using the app. Is it after work, before work, in the morning, while they're having breakfast, while they're on the toilet, etc. If you can pull that data in, have data scientists analyze the data, look across developers, especially like more junior developers, like myself and Ali. And I say that because we have like some heavy hitters, man, that have been in the game for they're in the game when like people were using like Fortran and I'm joking, man, I'm joking. No, but seriously though, what I would say is that if you can start to understand the domain that you're building, the business space, the business solution, the business problems, rather than just looking at the code, you'll become a more effective developer and you'll be able to implement more effective solutions. Like at first we'll be in a meeting and they start talking about the business problem and I'm just like I don't need to know this. Just tell me what to build and that's it, and I'll build it, I'll get it done. But now I understand as an architect and as a person that has had to build big solutions, implement big solutions, I understand how important it is to understand the business domain, understand the customer, even sit with the customer while they're using the app is extremely, extremely important while doing user testing, etc. So like we will have our development teams like sit with the user experience people while they're using the app, even the back-end developers, because there's always, it seems like something always comes out from everybody that plays a role in delivering the solution when we have the entire team involved in the user testing and they can see the user interacting with the apps. That's one of the importance of big data, but I'll talk about why was it important for our particular app. The use case. So the use case is that this energy company is having this, now my older slide said 250 million, but that's in like one segment of their population that they were just going to try to roll the solution out onto. But this is like, now they're expanding, because it was successful, they're expanding to the larger of their segment. $1 billion commodity usage problem, where if they could get their users to use less of this commodity, they can save hundreds of millions of dollars. The company. And not only that, they would also, the user would also save money, right? So what they wanted to do is, they wanted to implement an app. This is a commodity. Energy is a commodity where most of these companies are like way behind when it comes to tech. I mean, like, the user just receives a bill, and on my bill it said I use this much amount of energy, and that's it. It's like, and I pay. You know, I may call and say, hey man, why is my bill up? You know, they have these little graphs that are very rudimentary and very elementary, and that's like the highest extent of, or the farthest extent that they're going when they're, you know, telling you how much you're paying, you know, for your energy. So the user is just, you know, most cases just trying to find the lowest rate, and they go to these like websites where they, you know, show you all the lowest, like they give you the lowest rates. So I'm hopping from company to company like every, you know, time my contract ends. So this company is trying to figure out how to help the user change behavior, you know, wash clothes at a different time. When energy costs are at its highest, they're encouraging them to, if it's a warmer season, encouraging them and showing them how to use, how to save, use their AC more effectively. If it's a winter time, sharing with them tips about how to, use their heat differently, etc. So also with the tips and the education, they add a little bit of gamification, right? So there are rewards for, in your region and with your same house type and your same number of people in the house. There's like leaderboards. People that really got into this. It's like, it's like people that are in their 30s, 40s, like really like getting into like being saving the most energy in their particular town, in the same house type, etc. So they're winning badges for saving a certain amount of energy. They're winning badges for being the first to change their light bulbs, and it kind of goes deep. There's a lot of different things that you could do, but they wanted to try to decrease the commodity usage by 5 to 10%. That was just it, right? If they can get this app that the user has could help change the usage from 5 to 10%, and it was successful. It was successful through education and gamification. What they would do is, and we'll get deeper. We present, how much the user would use. You'll have like a graph of your 15-minute usage, a graph of your daily usage, a graph of your weekly usage, and your monthly usage. So you can see whenever I pop up the app, I use this much yesterday, or the day before, or the week before, etc. And we used D3 to create highly custom graphs, zoom in, zoom out capability, stretch in, stretch out, historical views, etc. And then we use the data scientists to look at, and some algorithms for us to look at, if we're in June, we would compare this particular day in June to the same type of day in June and previous years, right? And say, okay, with this same type of day, you use higher or you use lower energy. So you did good or you did bad, right? So we not only consumed all this data, or had all this data, but we had algorithms to look at replicas or of the same day or days that were similar in order to let them know when you had a similar day like this, and we had these comparisons. In the graphs we had comparisons as well, and we'll kind of get to it. But yeah, so it was the presentation of the data in a fun way, then also the gamification aspect that drive the changes. Here we go. So we'll get into like the tech stack. So this is like very high level. There's a lot more components here, and we'll kind of like get into a little bit more. But this is like just really at a high level. So for mobile, what we did was we built a hybrid app, and to some surprise, you may worry about the efficiency of the app. You may worry about the speed of the app. You may worry about the reliability of the app. But surprisingly, with millions of users, it proved to be very reliable. The build was solid and efficient. And we had choices. We could have used React Native for this. We could have used Native Script. We could use Xamarin. But we used Angular and Ionic. And this was just based off of the skill set of the team. So we use Angular, Ionic, and of course we use, if you're familiar with this particular stack, we use Cordova as a wrapper of this web technology. So it was HTML5, CSS, and this allowed us to use our web developers that we had that had experience with JavaScript, HTML, and CSS, and we didn't have to have two code bases. We didn't have to have Xcode and Java. And we also use SQLite to support our offline as well. And then D3, it's like there's a lot of these libraries like Chart.js, and there's many of these libraries that throw up some little charts for you. A lot of those have restrictions. D3 is like, you can customize it to create almost any sort of graphical representation of data. It's very, very sophisticated. It's kind of hard to get into, but once you get over the learning curve, you can create amazing looking things and very highly customized things. So that was like just a high level what was in the mobile stack. So here we use AWS. So we had API Gateway, if you're familiar with AWS at all. We had Lambda, we used EC2 for some things. We used Node.js for a lot of the building of the APIs. We used Python for a lot of the processing of the data. We had to send messages like text messages, email messages, and notifications as well. A lot of those, like when the user was signing up, we had multi-factor authentication in the app. So we would send them a text message with the code. All of those things went through the SES service. And then Amazon Cognito is what we use for authentication. And then we use S3, one of Amazon's storage buckets. DynamoDB is their NoSQL database. And then RDS, we use MySQL for some of the data store as well. And there's another, there's more under this stack, but these are just sort of like some that kind of stick out that you may know about. And then also we had continuous data streams bringing in like external data from different sources. So I kind of get into like all the data that kind of went in to building the app. It wasn't just like a simple, just show, some profile data or form. There's a whole lot of data that went into to building the app. So here we go. All right, so I just kind of threw up a few things here, just kind of show what sorts of things were in the app. So general personal profile data. Because this is an energy app, there's friends and family profile. Like if I have a house and I want to add my wife, so she can look at our energy usage and she can have the app. She has her own profile that's connected. There's a house profile, so I may have a two-story house that's 4,000 square foot, 5 bedrooms. And this is important because during the gamification, we had to, people's level or the boards that they were a part of, it had to be equal. I mean, if you have a 1,000 square foot home, of course you're going to use less energy than somebody that's a 4,000 square foot home, right? So there's a house profile that's connected. There's data related to the customer's energy plan. We had rewards and badges, data that were stored. Also, there was billing data as well. So they have the ability to pay their bill in the app. So you just imagine there's an app where you have your profiles, you have the ability to edit your profile, you have billing data, so you see all your past bills for every month. You can pull them up in PDF as well. You can pay your bill through the app. And then there's company data, like company-related data, like plans. Like there's all these different plans that allow the user to switch plans in the app. So they're on one plan. If they're ending, if their cycle is, if their contract is about to end, they can switch their plans. So then there's pricing data associated to those plans. And then we had forecasted for them data on how much they would save, right? So we had to have we had to have their current billing data, which I showed here, and we had to use some methods of deciphering how, based on all of their energy usage in a particular month, we could show them if they switched over, like on their graph, what their energy usage would be and then how much they would save. So then we had captured app behavior data, right? So we captured page views, how much time they spent on the page, the funnel, right? So like they would go from home to the usage page to their bill. We captured all of that data and sent it to the back end. Also, there's these in-app responses. So we would show them tips like, in order to save money this winter, you should seal up your windows. And then if they said, I've done this, they would send that response to the back end. And based on that response, we had a queue of other tips that we would send them based on that particular response. So we had to build out all of these, this catalog of tips in the back end. And it was like a queue. So it was like tip 1, question 1, they selected this, and they would go to tip 2 in this particular tier. So we would show them all these tips just kind of popping up in different sections of the app. And then their gamification rewards that we stored. And then we purchased a lot of data as well. So we purchased demographic data, psychographic data, pixel data, and other miscellaneous data that we sourced from different sources. They spent a lot of money on data in order to do some of their data analysis on this particular group. And then we had some open source data. We pulled in weather data as well because we needed we would show them the weather when they opened up their phone. But not only that, we needed the weather data to help us do an analysis on like what affected their usage as well. So like if it's very hot, if it's went up to 90 degrees in Houston, our ACs are going to be blowing harder, right? So we would want to see like patterns that would say, okay, if we're in August and it's 100 degrees outside, then our AC should be going up. But if the temperature is declining, then we should see the energy usage declining as well. So we needed weather data as well to help us with those analysis and help us present.
Make predictions, right?
Yeah, make predictions, right? Because that's how we would forecast. We would say, we would also allow them to put in like a goal to say we only want to spend $200 this month. So we could forecast and say, you know, if you're 15 days in and you look like you're not going to make your goal, right? Or you look like you are in good standing and you're going to make your goal, right? So you can imagine we had all of these different requirements to build the app and to make it function. And then we had some geographical data for Canada as well that had to play. So this is all the data that the app was using. And you can imagine like what kind of exercises we had to do, had to go through while building this out. So one of the things that I know this is a whole lot. Does anybody have any questions? Am I losing anybody? I know I may be rambling on.
What is pixel data?
Huh?
What is pixel data?
Oh, pixel data. Okay, so the pixel is it's like a tracker that is placed in
On the web page.
huh?
On the web page?
Yeah, on the web page. Yeah. So like it'll track all the websites that you go to, and this is how Google serves you up all these different ads. Yeah. Right. So Facebook has a pixel now. If you register with Facebook and put a pixel on your website, when you're serving Facebook ads, you can serve more effective ads because the pixel will tell you that this user is of a particular demographic. This is the certain websites they go to. This is their age, etc. It'll end up figuring it out based on all the websites they visit, right? So we purchase this data in order to more effectively give them tips and just know more about this user. We're trying to create these like profiles in the back end about this person and their behaviors. Because eventually what was to be done is that if we can find out that your refrigerator, like these big appliances, are causing you to use more energy, what we would be doing is we would be recommending that we would be developing a relationship with Target and your Best Buy and your Sears, these companies that sell these appliances, and we would do some sort of discount and recommend that you replace these requirements, these appliances. Yeah.
How have you made the recommendations? Have you done this, automatically, or for people, some people, like moderator, they were connecting just, content that for this situation, this tip, and for this recommendation, for this situation, there's another tip, and so on.
Yeah. So we had a content team and research team create an initial set of tips, and then as the user used the app for like 2 years, we had the data scientists. They work with the content team to say these are the patterns that we're seeing, and then we create more tips.
So you built a recommendation system?
Yeah, we built like a recommendation system.
But
Yeah.
at the start?
At the start.
It was manual,
It was manual, and just based off of like all of the data that and the research that we had, it was all manual at first, so just an initial set, and then eventually we groomed like a recommendation system.
Is there any IoT data?
So, okay. So there's, we attempted to, there's no IoT data. We wanted that to be eventually a part of it, right? So that may be like phase 5. But there's this thing called, man, I can't remember, it's like slipping my mind. But based off of the usage patterns, if we can get small enough usage patterns, like down to like, so right now it's like 15-minute energy data. If we can get it down to smaller, then we can tell like what appliances are using, like through disaggregation, we can tell what appliances are causing the spikes in the energy usage.
Because you know the energy signature, basic energy signature of most appliances.
Yes.
And you can, if you have the window short enough,
Yes.
you can kind of narrow it down, like maybe it's the dryer, washing
Wash
machine,
machine.
and refrigerator, have similar voltage draw. So you can kind of figure out maybe which one is causing the spike, and then you can.
Yep. So that's so we'll take that data and just aggregate it, and then in the app we will say, look, your dryer's using this, your washing machine's using this, your refrigerator's using that, but we had some issues. We tested it out. We just weren't able to get it small enough. Yeah.
Is it real-time data?
Yeah, it's all real-time data. Yeah, it's all real-time data.
What about the development period?
So.
What were the problems?
Yeah. So I'll get to some of the problems.
Some soft problems.
Yeah. No. I mean, this was a Herculean effort. You know, it was definitely a Herculean effort. This was a 40-man team. You know, we had a design team, we had content writers because they're controlling the UI. They want the content to be sharp. You know, we have all these messages. Then we had a big development team, front end, back end. We had data scientists. So yeah, we ran into issues for sure. And we have all of these out. We're pulling in open source data. We hit API limits because they're pulling in too much. So it's all kind of stuff that's happening, right? So yeah, we'll talk about more. But yeah, so I think it took us about 6 months to do our first release. Yeah, it took us about 6 months to do our first release. And then from there, you know, we had releases, like we had, you know, 1.0, then 1.1, and then 1.2, 1.25, 1.26, right? So all of these small releases where we're finding defects, hammering them out, doing another release.
For the energy usage data, did you guys go to the meter manufacturer who collects the data on behalf of the utility, or did you just end up getting it from the utility?
So this particular utility, they own the whole like vertical. Yeah, so it worked out. It's easy, yeah. So like before we did this with this utility, we did a Texas, pilot, and we had to get the meter data from the manager. I can't remember the name of the company.
Ion?
No, it's another one. But it was painful because they didn't have an API, they didn't have a stream. So it was all like CSV batch data, and we would get it like every night. So it was a little bit more very latent. It wasn't like real time. We couldn't, and actually we didn't get it every night. I have to put this code in. It was more of like we would get it like 2 or 3 days after. So if the user was using the app, it was not a terrible experience, but it wasn't like real time. They would have to wait, right? But yeah, I'm gonna hurry up. It's like 1:50. Let me hurry up. Get through. And we'll talk about some other problems. Let me see. Could not connect. Okay, yeah, so, and this is very like high level. Of course, there's a lot more going on. But just, so one of the problems I wanted to point out was that, on the phone, we had to call, and this is some of the things Farouk was talking about. But once we brought in the external data, once we brought all this data in, right? We created all these APIs that we would use to call and bring the data into the phone, right? So we have profile data, billing data, minute usage, daily usage, weekly, monthly, etc., right? So we end up with all these APIs that we need to call in order to populate the data on the phone, right? There's a bunch of, let me see. Okay, so here, depending on the business requirement, this can be easy or this can become very difficult. Let's say like if the requirement is just like every time the page loads, we'll load the data in once the page loads, right? So it's like when I go to the profile page, serve me up the profile data, right? Don't bring it in before, and I don't care how long it takes. Just bring in that data when I hit the profile screen, right? So that's one way, right? But if we're serving people, and this is one of the issues, we were serving people that had 2G data, like on their phone, like slow internet speeds, right? So we had this wide range of like internet speeds that we had to serve, right? And then another, so that's one thing. And then another thing is we have these requirements from the government of how, because the government is very closely to the how the energy is regulated and how this app was done. So we had these requirements of load speed, of load time, like how fast the UI had to load as well. So we ran into some issues with having all of these APIs and having to call them and populate the data. So I'll just kind of tell you like how we kind of done it, how we kind of did it at first. So at first, what we did was we would just, when the phone loads, like when they open the phone, behind the scenes, we would just fire off all these APIs. So that, you know, before I hit billing, before I hit profile, before I hit any of the screens that I would go to, in the back end, I would just be pulling in the data, right? So then by the time I got to the screen, my data should be there, right? It should pop up without an issue. So that was okay. When we had like a few pieces of data. But as the data grew, right, the times became slower because we end up with more. Because we start, like at first we have profile, that's it. Because we're building in iterations, right? Then we have billing, then we have this usage, right? Then we have plans, right? But as we start to add more APIs on, it starts to add more seconds, right? So we're at 1 second, then we at 10 seconds, then we're at 20 seconds. And then I literally walk in and dude's like, man, it's taking 50 seconds for for the API call to be done. And I'm like, that's ridiculous, or whatever, right? So that's one problem, right, that pops up. So another thing though is that we have to support this offline as well. So meaning that, like, if I'm on Tuesday, if I load all the data in on Tuesday, and on Wednesday I don't have connectivity, my experience should still be the same, but I only see the data from Tuesday, right? So I can look at all my graphs, I can look at all my billing data, everything that I have without losing experience. I'm going to tell them that they lost, they don't have connectivity, they don't have internet, but the experience should be exactly the same, right? Those are like the two, like that's a requirement, right? So what we end up doing is that I'm going to skip through some of these slides. Okay, so we talked about the offline requirement. So one other thing, so fully functional offline, historical views should work. Also, the user responses. So we have these tips, like did you change your light bulbs, or did you turn off your AC when you went to work? We have to capture these responses even offline, and then when they gain connectivity again, then we have to fire them off and send them to the backend as well. And then also we store behavioral data even while they're offline. So we would just say, the status is that they're offline, but they went to these pages, they viewed these things, etc. And we have to fire that. We have to store it in SQLite, and then fire that information off when connectivity came back, right? So just kind of talking about some requirements before we dive into some of the issues. So this is just a diagram that shows if there's no connectivity, we can't go to the back end. We would go to SQLite and gather the data that we have on the phone. Okay, so here we go. So back to the APIs, all these APIs. So here's some issues that came up, right? So one, millions of data calls, possibly unnecessarily increasing infrastructure, resources and costs. So one thing is that if I'm loading every time we refresh, it's maybe unnecessary. So it's like, okay, if I got my billing data only comes every month, right? If I'm making a call to the billing API, every time I refresh, it's unnecessary, right? So you have millions of users loading their phone, and they're unnecessarily making calls to the billing API, right? So that's just unnecessary costs, that's unnecessary data being used, etc., right? There's some data that was only refreshed weekly, right? There's some data that was only refreshed daily, right? So that's one thing. Then we had to support low internet speed, or people that they didn't have unlimited data plans, right? So we're making unnecessary API calls. We're using the user's data, and they're going to be mad. They're going to give the app a bad rating because when you go inside your app, you can kind of see like what's using all your data. We're making all these unnecessary calls just because it's convenient for us to just make a refresh every time, right? So then there's more issues, user-related issues. We can talk about development-related issues in a minute. These are user-related issues, right? And some infrastructure-related issues. So what we did was we initially came up with tiers, right? So we tiered the API calls. So it's like we only fetch when necessary, and we implemented a data fetch schedule. So there's some APIs that we would refresh every time. So call the API every time the app is open. Then every 15 minutes, like there's messages in the app. So like, Facebook, we wanted to keep the messages fresh. So every 15 minutes, we would fetch the messages, we would store SQLite, a timestamp, and then whenever they open the app, if it's been 15 minutes from the timestamp that we stored, then we would go back and refresh the messages. So just so that the messages that they receive could be fresh, right? So that's something that we would need to call often. Then there's a daily, some things that are refreshed daily, like their energy usage. There's a specific time of data calls. But there's still problems with this. What could be some of the issues with this?
Ad hoc refreshment.
Huh?
Ad hoc, I mean refreshment.
Ad hoc refreshment. Ad hoc refreshment. So this is, we like literally hard coded this schedule in the front end. But in the back end, if new business rules come and there's new refreshment times, then we have to literally make a new app release, right? We have to release, and we have to wait for Apple to approve we have to go through their 2-3 day, sometimes 5-day release cycle, right? And then Android is just, Google is so funny. It's just like, you just throw anything out there and they just like accept it and you go. But Apple is like one time we changed the color and then like, you had this color change and something about the users and this area is offensive, this color is offensive. And we had to make all these, we had to send in like some justifications for it. I mean, they're really very meticulous. Apple is, but yeah. So this was it was a good idea, but this optimization was flawed in that way. We have to make another app release. So next thing we tried was this. Okay, so what we did was we came up with we called it a master delta API. On the server side, what we did was we would, whenever there was refreshes, we had a special table that would log that these specific data sources were refreshed. So from the front end, we would send like a timestamp with all of like the different APIs saying this is the last time that we've refreshed. We would send that to the back end, and the master delta API would scan and see what had been refreshed since our last refresh on our device. And then it would send back, we had two options. We could send all the data back in one API, but we wanted to keep everything decoupled. So it would just send back saying profile API, true, false, for billing API, leaderboard, true, savings, true, true, false of which APIs we should call. And then we would make the call, and then we would get the data. So this right here was much more effective user. And we would go to that table and say, when's the last time for this particular user, just like a column. In the table, not a bunch of tables for, not a table for each individual user.
Okay, yeah, just part of the profile data.
Just a part of the profile data, and then for their usage data, for each particular table, we would attach a column that would let us know when it was refreshed.
Gotcha.
Yep.
Now, the question I have is, that means that you have a master database where all this information are kept, which serves as like a big data behind. So as every user is updating his own profile record, is updating the data.
So that was like the kind of the same question Mukhtar had. So we didn't create a master table. The API itself would just go to the table, like we had a profile table, for example, just to keep it like simple, right? And your record of your profile data was in that table, and a column on that record would let us know when the last time it was refreshed. You had like a timestamp on their particular record. So your user ID 5, and then you have your first name, last name, address, etc. And the part of your record set was last refreshed. A column like last refreshed.
No, I don't understand that.
Yeah.
I'm only talking about, you see, according to the title is from to master, what do you call it?
The big data part,
At
yeah.
the end of it.
Yeah.
I'm looking at it that this app now gather information, personal information,
Yeah.
and make it available for the data. Alright? Maybe let me reframe the question.
Yeah.
Okay. What is the contribution of this app to the big data?
You mean like the big data sphere of all the data? Or you mean like
Where every other person can query
Yeah,
for some other use.
yeah,
The big data is
Yeah.
everything done,
Yeah.
different. Then everybody can now say, do you have this in this data? Okay, get it and make meaning out of it.
yeah.
Now, this particular app is a kind of a media
Yeah.
via the data is fed to the big data.
Yeah, so, what
Now-
the, yes,
So,
yeah, no, go ahead.
now, the question now is this. What is the legal? There any legal implication? Number two is, will the user is aware that his data is going to a database?
Yeah, so, when the user signs up for this app, we have a little, there's a little link at the bottom that says, do you agree that the legal team wrote all of the terms and conditions and the privacy policy that says you can sell my data to the highest bidder?
No.
You know,
Anyway, I get your point because
edit that part out. Yeah, but seriously, so there's a lot of behavior, like, so for utility companies, are companies that are related to the utility space, all of the behavioral data is what could be valuable to them. How the user, how much, their usage data, but then also like what sort of behaviors changed. And then if we can add the disaggregation, like we can say, we can show like patterns, amongst weather, among certain geographic, when it comes to their big like the refrigerators, the washer, the dryers, etc. And we can sell that data to consumer retail businesses or people that manufacture certain appliances. Then that could be value for them. Hmm?
That leads to another question.
Yeah.
Now,
I like questions.
yes. The interest of us in this room is to see how you put
Mm-hmm.
the opportunity presented.
Yep.
This is an app. Is this a cost to the user or cost to the manufacturer?
This particular one. Yeah, this was to the business.
The thing is, you have this app.
Yep.
For this app to achieve its aim, the more people subscribe to it, the better it is.
Yeah.
Now, what is the strategy that make people want to go for this app?
Make the consumer want to go for it.
Yeah, because
Yes.
something must attract them.
Yeah. Yep.
If you must get data from me,
Yep.
it's like carrot and stick and monkey and carrot, stick and monkey.
Yeah.
Or banana,
Yeah.
stick, monkey.
Yeah.
Monkey wants banana,
Yeah.
then there must be, you want to hit the monkey.
Yep.
So present the banana,
Yep.
hit the monkey.
Yep. So for
So what is the banana here?
yeah. So the banana here.
Huh?
Yeah. It's the cost savings.
You
So if you
down the idea of how to save our energy.
energy is so
want- Yes,
so
that
for
is it.
so for people that are upper class, they may not care. They may not care about, and I don't care if I'm spending, if I can save $50 or maybe even $100. Some people they don't care. But middle class, lower middle class, or people that are just budget conscious, it can help them visualize for them their usage, and then gave them tips on how they could save by changing their behaviors. Yeah, so it's the cost savings that was beneficial for the consumer. Yeah.
Accomplishments also, like that. Maybe
It's the gamification. That was another part. I mean, we don't really have time, but the gamification was a very, very interesting part of this, which I had like a little graph here about how this a high level graph, then like further down, like it's more. But the gamification was like a big part of it. I mean, I was surprised, like the business, the product development team, they're talking about how the gamification is going to work. People are going to go crazy about, saving money on energy. And I mean, people were just like in it, man. These leaderboards and people on Facebook sharing that I was the highest, I won first place and I got this badge, man. We had about 25 badges, and people were just excited about getting and sharing them on Facebook, so the gamification works. It works. Big time.
Share the data, right?
Yeah, so you can share with a friend, you can share on Facebook, on social media. Hey, I use this particular app. It helps me save money, and also I ranked, number 5 in my zip code for saving data. Yeah, so we had like a little share function, like that was. And so we had app notifications, like We use like push notifications for different alerts, because they have like critical times and like weather, like it may be like freezing cold, so we had to use push notifications. Everything you can think of, like it was a whole lot of things that went into this app to get it done. Yeah. Profile pictures and all that kind of stuff.
Because, I think for this type of apps to really gain ground,
Mm-hmm.
for people to gain acceptance, because that is important.
Yeah.
I think it has to do with a lot of goodies.
Yeah, yeah, yep.
Goodies that, oh, you can use this one, maybe getting the weather situation in your surrounding.
Yep.
You can use it to get the nearest
Yep.
having job and all. Something that, or direction.
Yeah.
Now, you mentioned something there concerning geographical
The
data.
visualizations.
Geographic.
Oh, the geographic, yeah, geographic data, yeah.
Does that have to do with the GPRS?
With the GPS?
GPRS.
The
GPRS.
GPRS. Oh, it was more, the geographical data was just more about, so like you may have like a home that is sitting on a particular hill, so the sun is shining a certain way, but they don't get the sun until it comes over a particular time of the day, right? So, and this may be in the same neighborhood, you have the same size house. In order to heat their house, it takes this house, this one house, more heat because they're blocked by this particular hill, and the sun doesn't shine. But just like down the hill a little bit more in the same neighborhood, this house is getting the heat the entire time because the sun is shining on it. So different things like that, like that kind of data that we would kind of like get. I mean, it's kind of a stretch, but you know that's the kind of stuff that we were getting, like you know, all the stuff that's related to longitude, latitude, geo points, and all that kind of stuff. But last thing I'll mention is since we use Ionic and Angular, we had like some real serious like there were defects bugs in the framework. So we actually logged pull requests for like bugs in the framework, and we actually had to have them fix them. I mean, we proposed the fix, and they pulled our pull requests into their open source code. So like, and we use Stack Overflow like crazy, and like I use like I have a video on YouTube like. Yeah, you know, yeah, like, so what I did one year, I answered a whole bunch of questions, and I gained like thousands of points. And I never thought I would use them. But for this project, I had to give bounty. You know, you can give like bounty points for people to answer your questions. So for this app, like I gave like 500 bounty points, 300 bounty points, like for people to come and answer questions. So they're like framework related bugs that really like, I mean, we were like, all hands down. We had like 1 month where we had like touch issues that were only specific to iOS, right? Those kind of things, right? Where like this one dude, this random dude came up, he's like a proficient expert at touch. And he's like, he found this little bug, and then we end up like I was just so thankful, but we were struggling for like a month because we had to really like start to understand like deeply like touch movements and things that, you know, that go beyond just like, you know, document selecting CSS selectors and stuff like that, right? So it was like multi-touch events, like with the thumb, if they go certain ways, etc. Like touch events were missing, like misfiring, right? So if you touch with the right thumb and then touch with the left may miss, so there's no zoom, right? So different things like that kind of came up, and that's what caused us the biggest headaches, was on the front end, using that open source technology, and it was fairly new, so we ran into bugs, and we had to like really go into the source code and read it and do a lot of debugging in Chrome the development tool with the emulator, and we had to like go in and do set breakpoints and like really like find out what the bugs were, and then log pull requests and have them pull like code in. So so that was one thing that we were proud of. Like some of our code is in their code base, and people are using it, right? So that was one of the big issues. And then we had like program management issues. Like we had project because we had a team we had an offshore team in India. We had an onshore team. So it was a lot. It was like some program management, estimation issues, all that kind of stuff that are kind of like, it's kind of general. But yeah, it's already 2:15. I don't want to hold everybody. 2:20. So I mean, we can talk more about it. I can just we can kind of close out, and then if you want to talk more, or anybody else want to ask any questions. But any closing questions or
Who you recommend the game?
the same?
Who you develop it on Ionic game?
So man.
Through all of these
Man, really, I would probably use like React Native. But no.
I'm only saying that because you get a trade-off when you use these frameworks.
Yeah.
You get the trade-off in saying, hey, I can take this web skill,
Yeah.
I can make native apps with it.
Yeah.
But when you start to get to the nitty-gritty of things that you need,
Yeah.
like, oh, this is one little obscure thing I needed from here. Then you have to realize, oh, I got such native code.
Yeah.
And then before you realize it, you might have to refactor something and say, okay, if I just did this in Java, I may have this problem. If I did this in, Xcode, I wouldn't have this problem.
Yeah.
Yeah, so it's like, is that trade-off? So long as you don't go too deep, it's like, oh, I need something like very specific from that, and it's like, okay, I can kind of sail
Yeah.
above it. And I guess that is another question. I know, so for React Native, because I use it a lot, you can incorporate Java directly into it. So
Yeah.
if you know Java,
Yeah.
then you can write something, you can write little add-ons or plugins for it.
Yeah.
Yeah, so can you do this for?
Yeah. So we actually wrote plugins.
Hmm.
So for Cordova, so you would write a plugin for Cordova.
Okay, so
you'll write a JavaScript, and not a JavaScript. You'll write a Java, and you'll write an Xcode, but you have to like write a JavaScript layer on top. And they have like this whole little system for you to be able to create a plugin.
So there is no direct, hey, I can circumvent the framework and write my own plugin.
Yeah, you wouldn't. I'm sure it could be done probably, but you would use the Cordova framework in order to create the plugin.
Gotcha.
But you can do it. So if you know enough Java, you can access something on the device if you know Java. And that's what we did. We had to create maybe 2 or 3 plugins, like small plugins, because the framework, they hadn't developed anything that would give us access to certain things.
Yeah,
But-
sorry.
No, I'm sorry. But like to Mukhtar's point, for this particular app, I would use Ionic or React Native because we're not using like any crazy or very like we're not going to a particular granular level that we need some of the like we need to tweak certain device specific functionalities. So I will use it again. I will use one of the frameworks again just because of that particular case. But if we're like we built an app for pilots, and so like they're flying in the sky, and they have this flight pattern that we like develop. We use their flight pattern that they have and incorporated like a visualization of it on the iPad, and it was no way that we would be able to use like one of these frameworks with that because there's too much device specific functionalities that we needed in order to build that. But for this, I would use a framework again. Yeah.
What about performance?
Performance was good. I mean, like most of the people. So this is what we did. We didn't support like whatever iOS version was like the lowest version that Apple officially supported. We didn't support that version. And if you downloaded the app, we would tell you like, this is not supported, right? You know, if it blows up, we're not liable, right? And same thing for Android, right? So because of that, you know, we didn't experience some of the performance issues that we may have experienced. Performance was good, you know, from all the tests. Like we had a device farm with AWS where we tested on all these devices. So we wrote like, you know, unit tests and also end-to-end tests for like using Appium for all these devices that were tested, and performance seemed to be pretty good.
How much money did y'all spend 6 months to develop this?
How much money? Oh, yeah, like probably about like $1 million to do all of it, like first phase, but then, you know, more money as we go. Huh? 1 million. Yeah. But this app won an award recently, like 2019 Media Excellence Award for Utility Apps. It's a beautiful. I mean, the design team is amazing. So
you gonna show that?
Yeah, I gave it.
I mean, I'm not supposed to show it. He has a camera going, so I mean, I can show you offline. You know, yeah. You gotta edit that out. Don't blackmail me, but I'll show you. I'll show you.
What are the costs of infrastructure? I mean, on hosting on AWS?
What
Because all your infrastructure is
was AWS? Yeah. Like, what was the cost? Man, I can't remember the cost. I would just say for a company that spent the millions of dollars that they spent on the app, it was manageable. It was minimum, you know, for them to manage the monthly cost. It was minimum. It wasn't like outrageous, you know. It wasn't $50,000 a month or something. It just maybe a few, like 100, or maybe a few hundred, or like, you know, 1,000 or something a month. It wasn't crazy at this point. Yeah. Maybe when they open up to they're gonna scale up to more millions of their customer base. They start out with a small segment, and then now they're gonna scale it. They just wanted to test it, prove. We had to write a white paper and everything that proved that, you know, the app impacted the customers and caused them to drop a certain percentage of usage and all that. Yeah.
So from 6 months, you spent 1 month for Ionic.
Oh yeah.
How much time you spent with business, I mean, to understand the requirements? Did you have the ready prototype from there, or wireframes, or some mock-ups, or you did it yourself? I mean,
Yeah. So
all the talks from there, I mean, to build that empathy enough to start the development.
yeah. So like I think wireframing, like user research, content building, and the user design, all that probably took about a month. And so this is a design content team maybe of about like 7 to 8 people, right? So they're working on this like full time, like this is what they're doing. So yeah, so they kind of kicked it up pretty fast. And this is all they do. They just design. This is a pure design team. That's it. They don't do anything else and they're just all like the dudes that are just like, you know, they love colors, you know, and like and fonts, you know, and that's it. That's all. They're all Mac users, and that's all they do, you know. So they just like they kicked it out like pretty quick. They gave out Starbucks gift cards like to do like user testing and some research and stuff. Yeah. So then from there, so yeah, we had to do the wireframes. We had wireframing sessions. We had full visual designs like of all the screens of the app. We had night mode. Oh, I forgot to mention that. We had night mode. So night mode, after a certain time at night, the app would switch to black, all black with white text. That was another like cool like feature that they ended up putting in the app. But yeah, so that took about a month, like of the initial design. But of course, as we with like requirements and design, so like the RFP process, you know, they were like, you know, learning some requirements, you know, before we started design. So, I mean, the 6 months is just like, not necessarily the business requirements included, but that's just like design, implementation. Yeah, but there's like lead time for like requirements gathering, maybe like 2 months or so before.
What was the management methodology? I mean, did you use,
Oh man, yeah, man. We just like,
We used all of them.
we love Jira, man, and we love Scrum. I mean, like,
It was strict Scrum.
yeah. Like strict Scrum. Like, we had 2-week sprints. We did like, you know, our daily 15-minute stand-up. We did backlog grooming, sprint planning.
Poker.
Yeah. We did poker, like strictly. Like, I mean, our project manager was like, Really?
Clear Scrum.
yeah, like clear Scrum, and he's like a real. He was like a real Scrum master. So yeah, that's one of the things that helped us like stay on time. And we had like, you know, but we're looking at velocity. He's like, we're using Confluence as well. Like, I don't know if you use like Jira, yeah. So we're using Confluence. He's generating the reports every week because he has to, you know, report to higher, you know, like to the business and let them know, like, you know, staying on budget, all that kind of stuff. So yeah, that's how we did management. We did Git, Bitbucket for code repository. We had code reviews. So we had development branch. We had a release branches that we had, you know, for each release. We did hot fixes. We had production branch. We had
a dedicated branch manager. Guy dedicated.
I was like, oh no, it wasn't. He was coding as well. So like I was like one of the branch managers. So we had like 2 guys, just me and another guy, and we did code reviews as well. So anything came through. So like we gave the team like code standards, right? So like an entire like Angular code standards. These are the code standards. This is what we're gonna use. So if something comes through that's outside of that, kicking it back. I mean, you know, in a nice way, but you know, we're trying to keep a level of professionalism in the code. Trying to just think of other little things. So you know, we had dev, test, you know, prod, all that stuff. So we had a testing, like an internal testing application that was built in order for us to deploy Android and iOS test apps. So we had that going. Yeah, I mean, we had all the test environments. We had different APIs for dev, different APIs for test, different APIs for prod.
How large was the QA team?
Oh, so we had QA team maybe was about just only 2 people.
Okay.
Yeah. And one of the PMs like would, you know, so they had built all the test cases. We had one guy that was for automated testing, and one person was like the manual testing. So the automated tester, he would write all the automated scripts for the farm, and the manual tester, she had her set of test cases that she had to go through and make sure that the UI was functioning. Yeah, so yeah. We can talk a little bit after if anybody else wants to talk, but thanks a lot, man. Thanks for all the questions.